So children, today in Ellipse, we'll discuss some of the important basics, children, important basics. Okay. So children, see here slowly. Children, ellipse means oval in shape, children. Ellipse means oval in shape. Okay. So children, what is an ellipse? Seriously speaking, ellipse definition is defined as ellipse is set of all points in a plane, okay, where the sum of the whose fixed points is always equal to constant. Let me take here one fixed point f1, here one fixed point f2, and let me take a point p here. Okay, children. So what I mean to say is, children, sum of set of all points in a plane whose sum of whose fixed points is always equal to constant. Means pf1 distance plus pf2 distance is equal to constant. Means what? Means suppose I will take one more distance q. Imagine p is not there. Let me imagine only q is there. Suppose if I take qf1 plus qf2, that also will be k only. If here I got this answer as 2, here also I will get 2 only. It is a constant value, children. It's a constant value. Try to understand, children. No, sir, I didn't understand. It's one more I will show. Suppose there is a point R. Okay. So RF1 plus RF2 also will be K. Suppose there is point M. MF1 plus MF2 also will be equal to K. Means you take either this distance plus this distance, or this distance plus this distance, or this distance plus this distance, or this plus this, all the answers will be same. Or this plus this you take, or this plus this you take, or this plus this you take. Anything you take, the sum of the distance will be constant. That is number one. Okay, in the ellipse, try to understand. In the ellipse, okay, this is F1, this is F2, this is P. Okay, so PF1 plus PF2 will be always equal to F1, F2 distance. That is understood from the diagram only. This plus this definitely will be equal to greater than this distance. Okay, children, so PF1 plus PF2 will be always greater than F1, F2. That is number 2. Number 3, I want to give you some more introduction regarding the ellipses, children, regarding the ellipses. See, children. Okay, children, this vertex to this vertex from the center, if it is passing, the line passing through F1 and F2, the line passing through F1 and F2 is called as major axis. The line passing through F1 and F2 is called major axis, and the line which is perpendicular to major axis is called minor axis. Try to understand, children. The line passing through F1 and F2 is called major axis, and the line which is exactly perpendicular to AB major axis is minor axis. Okay, children, and this will be equal to A. This also will be equal to A. So A plus A is length of major axis is 2A. Length of the major axis is 2A. In the same way, what is semi-major axis? Semi-major axis means half of the major axis. Semi-major axis from here to here, it will be A, it will be A. I told just now. So A plus semi-major axis is A. In the same way, this is termed as B, this is termed as B. So length of minor axis is 2B, or semi-minor half minor axis is just B. And next important discussion, the point, this is 0 if you imagine, 0 F1 plus 0 F2, that is F1, F2 distance is termed as, this is C, children. So F1, F2 distance is C, 2C. Okay, children, this will be C, this will be C. C plus C from here to here, it is termed as 2C. It is termed as 2C, children. And what is the relationship between A, B, and C is A square is equal to B square plus C square. Okay, this is A, children. And this is C, children. This is B. So A square is equal to B square plus C square. Always remember, this is the relation which will help us to find out A, B, C. If any two things are given, if they ask you to find third one, you can find out. 2A is length of major axis. 2B is length of minor axis. And 2C is distance between F1 and F2. The line passing through F1 and F2 is called major axis, and perpendicular line exactly is minor axis. F1 and F2 is 2C. I hope you are able to understand till here. Next, two special cases I will say, children. Two special cases. What are the two special cases we will see? Number one, imagine there is no C. Imagine there is no C. A square is equal to B square plus C square, I told children. If there is no C, A square plus B square plus 0, A square is equal to B square, square gone, A is equal to B. Children, if A and B are becoming equal, can anyone say what will it happen? This is A and this is B. If A and B are equal, the ellipse will become what, children? The ellipse will become what? Circle. The ellipse will become circle because there is no C. When A and B are equal, there is no C, then the ellipse will become circle. Second case, children. If A and C are equal, okay, so we know A square is equal to B square plus C square, but I'm saying A square and C square are equal, so B square is equal to 0. So B is equal to 0 means there is no B. If there is no B, can anyone tell what it will become? Ellipse will become? If there is no B, then what ellipse will become? This B is not there. Here and here, this B is not there. It will become what? This B is not there. This line and this line is not there. Then what it will become? Straight line. It will become a straight line. Children, when B is not there, only A is there, then it will become a straight line. B is not there. In two cases, I have told in ellipse, children, if C is equal to 0, A and B are becoming equal, then it is a circle. If A and C are equal, if A and C are equal, then it is becoming a straight line. These are the two cases of ellipse. Okay, children. After this, then we are going to study what do you mean by eccentric. Eccentric is represented with E. Eccentric is the ratio of C to A. Children, what is C and what is A? You all know very well. This is A, this is A. This is B, this is B. And this is C, this is C. Okay, and C is always compulsory, 100% guarantee, always less than A. C is always less than A. So because C is less, A is more, your ratio will become always less than 1. Eccentric is always less than 1. Okay, children, C is always less than 1. Okay, so whenever we are taking on the coordinate axis, children, whenever we are taking on the coordinate axis, please see here, children. So any point coming here, we will take it as X and Y. Any point coming here, we'll take it as minus X plus Y. Can anyone say any point coming here, what we will take? Anyone?
Minus X minus Y.
Very good. Can anyone say what are the points here we will take?
Plus X minus Y.
Minus Y. And what is the equation of ellipse? And the equation of ellipse, finally, numericals will do in the tomorrow's class, children. And the equation of ellipse is X square by A square plus Y square by B square is equal to 1 is the equation of ellipse, where A is the length of semi-major axis, where B is the length of semi-minor axis, AA, BB, and X and Y are the points on the ellipse. X and Y are the points on the ellipse. We'll do some basing on this tomorrow class, children. Okay, I hope you understood all the basics, children. Very, very easy. Nothing will be there, children. I told you only one thing you just remember. Okay, this is major axis. What is major axis? A line which is going through two focus, F1 and F2. And exactly perpendicular of the major axis is minor axis. Major axis, this is A, this is A. Minor axis, this is B, this is B. 0 to F1, this is C, this is C. And the relationship between ABC is A square is equal to B square plus C square. Hope you are able to understand. This is how ellipse basics I have discussed, and in tomorrow's class I will tell how to do the sums basing on the equation of the ellipse. Anyone have any doubts, children? You can ask me.